I guess now it should be streaming on YouTube. Okay, what have we discussed last time? Jonathan.
I'm sorry, can you hear me now?
Yes, I do.
Great. Well, last time we checked some functions of the Pratt uh, gadget or the Pratt thing, and we also we also install a package for our studio, and that's also part of what we did last class.
Yeah, you took the idea of last class literally, but what about lecture? But anyhow, I think that's a great answer. Maybe we ask about lecture somebody else. Aisha, what do you think? Sorry, Aisha. We can hear you. Or maybe Sydney then?
Actually, this is my first time coming to this class. I just switched over from a different program. So I actually don't know. I can't answer that question for you.
Okay. Anyhow, nice to have you. But do you know the link to the webpage with all materials? Do you have
Yes,
it?
I have it.
Cool. So all lectures were recorded, so you can find video over there. So if you have time.
Okay, great. Yeah, I will
Okay,
be catching up over the week. So thank you.
okay. But anyhow, feel free to write and ask about anything. Okay, Masha, what was Masha Goldberg? What was the last lecture about?
Oh, well, we discussed different ways to analyze sound in Pratt, for example, and in R. And well, that's what I remember actually.
That's really strange. I was told that that's usually kind of man feature that when you send a letter to a man with 5 questions, for instance, he will answer on the first and the last one, and everything in between will be lost. But it looks like kind of all people uh, just pay attention to the last thing. So maybe I need to put there something important because everybody remember they are struggling with R and prod, and nobody mentioned anything about lecture.
Well, we practiced with R and Pratt. Maybe that's the reason.
Yeah, maybe. Okay, but maybe somebody, for instance, Anya, if I may. Cool lighting, by the way.
Sorry, I'll fix it.
No, it's fascinating.
Well, to be honest, I don't know because I missed the class and I didn't watch
Oh,
the lecture. Sorry.
sorry.
Yes.
I didn't intend to ask you because you missed. Sorry, I didn't know. Sorry. Okay, so maybe enough of this struggling because it's I think painful for all of us. The last lecture was about vowels, and for some reason nobody mentioned this. Um, so we discussed different vowels and how we and this tube model, so that we can uh, analyze vocal tract as a tube, and then assume that we have a tube in our mouth, and then model the frequencies that will arise from this tube. So do you recollect something like this? Those of you who've been there. I hope so. So do you have any questions for now? Because today, during the lecture, we'll continue more or less with the same beat, analyzing sonorants. And maybe, I don't know, maybe one day Inna will have a class about spectrum analysis. I don't know. Maybe it will be her classes. Wow, more cameras. Cool. Thank you, guys. I really appreciate it. Okay. So, do you have any questions about anything else? So, for instance, not class, homework, maybe some you have art problems that you want to ask, or I don't know, weather. Sounds like I'm too alone and haven't seen anybody for ages, but it's not.
I didn't have a question related to the homework. Um, there was a small fragment that the lady uh, mentioned, or she said something, but I couldn't understand. Were we supposed to to write down everything, or just the words you mentioned? Because there were some parts that I couldn't understand.
Yeah, this is the more or less standard question because during the task, for those of you who I think I can't remember when was the deadline for this, but the idea that I gave you some sound, maybe Andic one, and then you need to annotate some words, and I give you those words. So, for instance, I don't know, I can't remember from. I can have it on my. It should be on the website. Um, so another one. Yeah, so we have something like backup, wukudu, cheka, and tuka. Yeah, tuka. So the idea that I asked my informants to say these words 3 times, and after this there is a standard practice to ask people to say it in the sentence. And those sentences are differ, but it could be something like I said something 3 times. So for instance, big up, and then something like I can't remember Andic version, but nuni big up ira. So you will have something like this. And all the time, students ask me, should they to have a notes about Muni era and so on? So somehow eliminate those words and correctly write down them the transcription. No, you don't. You don't. You don't have any clues what the language is, what kind of sounds is there. You don't have any clue. Why should I ask you that? So the only part that you need is to find out this backup that is repeated, and I think it's possible to extract it from there. So there should be 3 times, and then in the word, but you see that it's there more or less. So I hope this answers the question. Okay. It looks like we are more or less alive, and that we can proceed with lecture. Um, so let's go on. I will share my screen, and I think this. Okay, it looks like this for today. So this lecture 4, and I guess it should look like this. Again, you see that this is the presentation from the previous year. Sorry for not updating this, but I think it more or less cool this way. So today I wanted to talk about sonorants, and maybe I will do that like this, okay? And maybe, do I need some chat? Let's have it over here. Okay, so all the time it looks like this kind of my favorite picture because every lecture I'm showing the same picture, and I hope that something like this will be imprinted in your mind somehow, and you will use this during I don't know what. So here we have the source filter model. Then we assume that we breathe out some energy, and then our vocal cords are vibrating, and then we change somehow our vocal tract in order to filter out some resonation frequencies for vowel formants. And this make these harmonics or regular repetitions are actually changed due to those filters, and then we see something like this. So we actually don't see exactly this, but we see this in formal formats. But I hope that you remember that it's possible to tweak out some prod specification in order to get those lines. So those separate lines that we have here. So this one, this one, this one, this one, and this one. So in playing around with the spectral window, uh, spectral window size, you can actually change it to something when you see something like more formant-like or harmonic-like. So we use this source filter model in order to model vowels. So the idea was that we have a more or less kind of tube over there, and we change it somehow. So those resonation frequency are changes. And that was uh, the last time lecture. And for some reason, I have it here. Is it possible? Okay, no, we have it. Yeah, so here is the more or less recap from the previous. So we have this tube model. We assume that this we can model with the, so we achieve those frequencies, formant frequencies that we can see here. And we model this with the tube. So actually, it looks like we can apply more or less the same approach to sonorants, because sonorants are mostly vowels, but with slight changes. So um, what kind of sonorants do we have here? We have here approximants, glides, and semi-vowels. So this is more or less the same name, but INNA actually don't like glides, I think, and semi-vowels are also a bit weird. So maybe it's better to use this first word, approximants. So those are w, w, y, r, y, I think this is y, but I'm not sure. It's we. So something we. This is present in French, for instance, when you have Louis and lui. But I'm not a native speaker, so I'm not any speaker of French, so don't. If you are, please think about this. I can't remember what actually. This is a nice question. Why do it's not a link? Okay. Why do I have this as approximate? Because it have different pronunciation, different varieties. So sometimes, I don't know, in somewhere, probably in Scotland, you can find this kind of sound pronounced with like r, so it will be erotic and like strong. I think guttural, it's something like Scottish word, should be Scottish. Guttural. But there is some cases, so when we talk about American English, it will be back, so something like tell me more, and so this will be retroflexed. So when retroflex sounds are those sounds when you round your tip of your tongue backward. So it's actually a huge class of sounds. So it could be anything like r, n, d, or something else. But there is some cases when we have r as a semi-vowel when it's not like retroflex version like in American English more, but um, it appears near the alveolar ridge, but it's not connected. So you see, you have something like r, 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 r. So when I say r, I actually don't touch anything with my tongue. So it looks like more approximate. So when we are talking about be careful, because it could mean anything. So sometimes it's approximate, but in some varieties it could be something else. Okay, I hope this is clear. There is also a huge class of sonorants that called nasals that, as you can get from this, pronounced with the nasal cavity opened. So for instance, m, m, n, 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 ng. Why I have three dots here, I actually don't know. I don't know any other nasal. There could be some additional articulation like colloquialization, pluralization, and so on, but mostly that's it. Okay, maybe I will change it in the future. There are also liquids. So everything that looks like L, lateral, and various version of R. And this is kind of overlapping because it's so liquids. This is a strange class that contains something like everything when you do something with the tip of your tongue. So various and liquids should be there. There are also rhotics when we have approximant and rebrands. So it's possible to have r. So in Russian we have, I think, something like this. So more or less one flap over there, and you have r. But you have it in maybe Spanish is actually famous for distinguishing perro and perro, I think, but I'm not speaker of Spanish and so on, but I think they distinguish the um, vibrant with the multiple bursts and tap with the just one burst. It's also present in American English. So, for instance, when you have British pronunciation better, but in American it will be better, better. So it will be better. It's not like rare, but better. It's one. Again, it will be just one flap with there. Okay, so is it clear? Do you have any questions for now? Cool. So
I
let's.
just wanted to say, sorry, that we have Jonathan who probably speaks Spanish.
Sorry, what?
We have Jonathan who can tell if there is a distinction between two ra in
Perro
Spanish.
and perro. Yeah, it depends of the place, because I think it's not in old Spanish, but I don't know. So
No, it is indeed. It's mark in spelling. It's
oh, you switched
sorry.
your mic.
Yes, in spelling is R and double R. Pero it's just one R, and perro is double R. So yes, there is a distinction between r and r.
Cool. And I think, and where are you from? Sorry, because it's could be
Mexico.
from Mexico. Because I think the word dialect when they don't do this, but I can't remember which. Because I think as a kid, my friend from Argentina, and he distinguishes this, but I think it was some Spanish, so Spanish dialects from Spain that don't have it.
There are some Caribbean Spanish that also they they don't pronounce it like instead of pero, they might say peo. I mean, they kind of chop it, but I think it's just some islands in the Caribbean. But I don't know, to be honest, about Spain.
Yeah, but it's interesting topic. Though. Okay, let's move on. So here you have different types of sonorants, and this kind of plan. So that's we'll go through today through this. So first is semi-vowels or approximants. So the vocal tract is relatively open for the semi-vowels and more or less the same as for vowels. So you have formants during the semi-vowel production, but they are consonants, and this is really nice thought, but it's really depends on what's going on. So because it kind of really hard to distinguish because in most languages there is a row that you are applied to. So when you have, it's possible to have more or less the same type of sound, but in different position, it changes the realization and it changes the interpretation. So, for instance, all semivowels occur in the periphery of syllables and not in the center. So it's not possible to have stress on them in most cases, but there are some exceptions, surely. So for Russian, we have dai. I think this is more or less natural pronunciation, and we interpret this as a separate consonant. Sometimes it's actually interpreted as a like how do you say it? So it's not like semi-vowel, I think, more like semi-vowel too. But it depends. So, but I think in most, I think that if you take any phonological description of Russian, you will have yeah, so the glide over there as an interpretation. And compare this with an English die, when we have more or less the same, so maybe vowels a little bit different. So, but the idea that they have diphthong there, and they interpret this as a diphthong, but the acoustic reality could be more or less the same. And this, we are coming back to phonology problems and phonological things. So phonological interpretation is something that is crucial for analysis because without it, you can't do anything. But with it, there could be such cases when, no, I don't. And
It's
this is strange because I even watched this video.
it's funny because in English they say like I think they say mine like because they're like something like that, and then in Russian they translate it like die, and then when you think about it, like to an English speaker it probably sounds like die. And that was funny. Sorry, just thought about it. How it might sound to an English speaker probably very frightening.
Okay. I know. But yeah. So the main thing that I wanted to say that it's possible that something that have more or less the same acoustic realization in different languages could have different phonological interpretation. Um, so don't be blundered by this phonological interpretation because sometimes people assume that it's there, but their realization is different. So um, they misinterpret something or so. So why is it? Why do we really care? Because if we have something like diphthong, we can work with it as if it was a vowel because it's possible to, for instance, to track the difference in the formant changes. So it will be when you have I, it will be vowel that vowel formants that changes during the production. So it starts with R, and then it became I. So you can see, and I think we play around with it when we turn on our vocal, not vocal, how do you call it? This vowel editor in Pratt. You can draw a line, and this will be a diphthong, and this corresponds to a difference in formants. So another example is English yo-yo. That is a toy. What and Russian yo-yo. When I expect the so the second syllable is stressed, but the um, uh, but it makes sense to, so phonologically we again probably will interpret this as two combination of consonant and vowel, but in realization it will be more like fricative. So in order to show you the difference, so when you, so what is the distinction between fricatives and for instance, sonorants? The fricative we expect that there will be some fricative sounds, sorry, some friction over there. So for instance, here the difference will be like y and y, y. So um, this kind of friction that you can see, and I hope that you can hear, will be different for instance, with compared to English speakers. And that's how you actually make a Russian accent in English. So this is a problem because in this more or less in the before the stressed vowel in Russian all you realize this fricative one. That's why we have something like with the strong Russian accent, you need to say yes in English, so it will be like yes with y and this part thing. And English speakers don't do this, just don't do that. So that's part of it. And this again will be what I meant. So it's possible to have one phonological interpretation, but the acoustic realization will be different, and that's why I'm creating this example. There are other examples. So, for instance, it's I think nobody used, again, it would be Russian example with the word theater. That it could be pronounced with in I think three ways, and only one of them is popular. So it could be theater, theater, theater. It could, sorry. So we'll start from again. So this kind of thing on the end we interpret as just simple sonorant, but actually it's really hard to say something like t and then r. So ideally it could be something like tia r. So something like this. But in most cases it's actually pronounced like theatre without the voiceless r. And this is how what circle beneath it means. So it's devoiced. Or otherwise, and I think this is more common, all speakers just make there some schwa intrusion. So there is schwa impentheticum over there that make it theater. And more or less the same going on in, I actually don't want to discuss it much, but I have a feeling that all those famous Czech and Serbian consonantal, sorry, uh, how do you call it? So it's sonorants
Syllabic,
that, sorry?
syllabic liquids, like
Yeah, so syllabic liquids. Yeah, that's what I meant. So all this kurk, prst, and so on that we have in Czech, that kurk is throat, prst is the finger. Uh, um, in most cases, it seems that something like really hard to pronounce because there is no any vowel and you need to do this. But actually, I have a feeling that they actually make their small schwa. So they do the schwas over there. So it's not like or krk or something like this, but it's actually kurk with, but I'm emphasized, but with the schwa over there. I noticed this because once I wanted to compare Czech and Serbian because they have more or less the same word, but I think prst is the same over there. Maybe even kurk. Kurk, I'm not sure, but I know. But the idea, I think, of Vulk. This was a nice idea. This was brilliant because it appeared that in Czech they have Vulk, and in Serbian they have Vlk. So it's actually for my. So I heard some recording and I had a feeling that they actually have schwa, but in different places. So um, in Serbian it was after this liquid, but in Czech it was before. But there are some interpretation when they, so some phonological interpretation when they um, think that they assume that this is like without any vowels over there, it's just um, liquid in the nucleus of the syllable. Uh,
May I ask?
yeah, sure.
Because, well, I'm a bit interested in Czech. That's why I asked once, like, what kind of sound. Maybe they have some kind of vowel, like, in between those consonants. And I was told that they don't have, like, any kind of vowel. Like, there is no schwa at all. But my question is, I didn't see any kind of spectrogram of, like, any Czech word like this with liquids. So my question is, if we look at the spectrogram, can we actually say if there is a vowel, like,
This could be a
also?
problem. I think this is a really nice question.
Because, like, when
yeah.
you can't, like, you can't see the border, like the line, you can't kind of cross it. Like, they're supposed to, like, be, I don't know
So
how to say.
the problem with the so they are different. So with rhotic, it's really simple because rhotic production itself, any something like or anything, it's actually work like this. So you have vowel, and then at the same time you you use your tongue or your uvular or epiglottis in order to produce some sound, and they vibrate at the same time. So you have vowels over there. So it's hard to say where something starts and where something ends, because if it's multiple bursts, it kind of continues. During the production of r, you have it all the time. So vowels in there, and this is like innate feature of this. So with liquid, it's a little bit harder because um, with liquid is also tricky because the border between, so it's really hard to mark a boundary between w and vowel with the next vowel. So for instance, you have wow, something like this. It kind of, we will interpret this as having three segments over there. W, ah, w. Then that's okay. Maybe if you English speaker, they will interpret the last one as a diphthong, as we've seen before. But the problem will be that it's really hard to mark a boundary. And so where you can show that it's not there or it's there, it's hard. During the production of L, you have the same story. So Adam, so for instance, when you have in Czech, they probably don't have the velarized L that I have, but they probably have something like Le or I don't know, Las or, but I don't know, Vulk. No, they don't. They have it. It's Vulk. So it will be something like, again, schwa, and then you have something like more some some movement of the tongue and then consonant. So I'm not sure that will be there, but we'll see the difference in formants, and we can interpret this as a change, but it will be also tricky because the formant changes are connected to the consonants around. So those are actually because of the consonants. So that's why it's a really tricky question. And I hope that uh, I've spoke a lot, but um, uh, mostly my answer will be no. It's really hard to draw a line between them. So how do you prove that it's there? It's hard, and I think it's hard. It's even hard for vowel. Why we interpret something that in some languages will be uh, so wow. I think in vowel. No, in Russian it will be two vowels over there. We'll interpret this as two vowels. But in some languages, it will be interpreted as labiovelar approximant w, then a, and then w. And why we interpret the last part is so. I don't asking about the first part. It's the problem even with the last part because why do you think that the last part is a consonant or vowel? How do you draw a line? It's actually something like phonological model that we use that will and we work within this model. But this kind of open question you can interpret this way and this way. There is no any clue that will say that is different. Make sense? Cool,
Thank you.
cool. Okay, let's move on. English is also a tricky language because we have something like button, and this again, how do you pronounce it? Because this could be tricky because in all transcription you will see something like button or something. So you have this t and then no. American English will be do some no, I don't know. Button.
We have a native speaker here.
I know. I think it will be just a row. So you know the problem with native speakers that so they can answer only simple questions. Uh, so this could be so in American English it will be button. So no
Button.
button.
Button or so yeah, it would be a like button with a glottal stop, or it would be button with a flap. Kind of just depends on the speaker, I think. Because now, yeah, like the problem with native speakers now, when you ask me, I like can't remember which one's right. And I grew up like my dad's British too, so I have like a weird influence of different Englishes in my brain. But I think it would be, yeah, I think it would be like either a stop or a flap or a glottal stop, but it wouldn't be like button.
Yes, I think this is important. So in some Englishes it will become a glottal stop. I think in some definitely in some Cockney varieties, but I think in the non-Cockney Brits also do this. I think so. It will be button, and this will be fast flap. So it won't be something like button or something. But the problem, since we have something like this in the end, what is that? So we have something like voiceless over here, but why? So what's going on over here? Is it like syllabic or not? Is it any vowel there? We kind of treat it as it's not there, but is it there? So this could be a really tricky thing. So is it syllabic and in the end or not? Is there any syllable? Is there any vowel? Sorry, or not? And another story, I think Tanya is not here, but should he? Should she? Or maybe she's
No.
here.
Tanya is like the second year student, and we are the first year.
Oh, wow. Is it so? Okay. No, no
Which
way.
Tanya do you meant? Did you meant?
Wow. It's how time flies. It's really fast. So the idea that we have these Mandarin languages, and all of them have a pronoun I that is actually ng. And it could be okay, we can deal with it because it will connect to everything, but it appears that it's possible to have different tones on it. So they have different realization of tone on it. So it's attached some grammatical features that marked with tone, and it's there. So it became syllabic, and then um, you can find it. So this idea about the that sonorants are actually consonants is tricky because they are half. So they are really, really like vowels. It kind of we expect that the intensity will be lower for semi-vowels, but it's not always the case. Okay, so we can move to the next slide. Here are some semi-vowels. And since articulation of those vowels is really similar to corresponding vowel, so we can actually expect them to be spectrum to be similar. So w and sorry, w. So this is actually a weird guy and really rare. So the first one over here, sorry, because it's bilabial approximant. So it's something like when you attach your lips and doing something like w, w. And this is a little bit different from the most common sound in the world that is w. So w and w, they are a little bit different, but the spectrum will be more or less the same. Is it clear what's the difference or not?
I have a question because when I did the last the homework first time, I just found that the ukudu, the third time the informant pronounced just like it's hard to be separated from the u consonant, the semi-vowel u and the vowel u. It's a little tricky to separate.
Yes, this is, I think if I understood your question, Vanshu, this is really nice question because in our homework, we need to place a boundary between w and u. And how do you do this? It's impossible. So whatever, so it's really hard. So sometimes there are some clues for this, but in most cases, it's just some spectrum from one sound to another, and it's important. It's impossible to create a new line. But don't be afraid because since we can't have any boundary, it's clear that our assistant also won't know where to put a boundary, and I asked her to treat this as as like as possible. So don't be afraid that you will have something like so punished for moving boundary 3 milliseconds left or something. Okay.
Okay.
Yes, but this is actually a tricky question. How do you distinguish w and u? And when you have it, it's impossible. That's the question, and that's the answer. But I wanted to ask you, did you get how do you, oh no, it's here. So did you get the difference between w and w? Maybe it's better to pronounce with some vowels. So for instance, la and wa, wa, we, wu, wa, we, wu.
One of them is bilabial and the other one is labiodental.
In
No.
most cases, it's inverted like labial velar. So it's labiovelar consonant. So the second one is labiovelar, and this is what we have in English. I don't know, in any English, in any, in a lot of languages. I expect that that Wanshu's name is actually starts with this sound. Who else? Yeah, more or less.
Could you please pronounce them again?
So the labiovelar, it's similar to English one. So it's we, wa, wo, wu, wea. It's impossible for me, but let it be. And when we have bilabial approximant, it w. So it's w, we, wa, wa, wea, or something like this. So the constriction only here, only in labials, or it also accompanied to the constriction in the, so the body of the tongue is going back. It also could be interpreted like we have w, but with the velarization, so when the tongue going back. But yeah, for some reason it's really popular sound, w, and it's a really rare sound, l. We can actually even look up how it's possible to actually to look how popular they are, I think. Um, so there is a database that called Foible. Maybe it's possible to do not with, maybe I show it first. So there is a database that called Foible, and you have different inventories over there. So, okay, I need to turn on VPN in order to work with it. Okay. So over here we have inventory language, have, what's going on? Maybe I didn't turn it on. I didn't. Okay. Now it worked. So here, for instance, inventory, language, number of segments, number of segments, number of vowels, number of consonant, number of tones. And here is, for instance, Abau. I don't know where it is, in Papua New Guinea. And I expected here. And here is the list of all segments for this language. And it's also possible to point here and see the number of languages that have w, kind of all of them. So as you see, so I think only those languages that are present with this sound are present over here. So you see all languages in the world have this. Let's how if I want to search for more, I need to go here and type something like this. And this sound present only in 71 languages of the world. You see it's really poor in Australia, no. In New Guinea, no. In North America, no, we don't have it. Africa is poor with it. And for some reason, it's like a collection of different weird languages in Europe. Serbian. This is strange solution, but anyhow. It looks like it's interpreted like, no, it's Komi Permiak. Okay. So some Ugro-Finnic, some Slavic, Ukrainian, Slovak, Croatian, Slovak but not Czech, strange. Upper Serbian, Croatian, Slovenian, and so on. Okay, so something like this. So it looks like really rare sound. So, and another one, so this is bilabial. And the previous one is labiovelar. I think it's nice to know about this database. It's also possible to download those data and do something with them. I think it's nice to know about it. I will put in the chat the link to the website. Here it is. Okay. So let's go on. Where are we at? Here. So talking about the acoustic features, again, they will be more or less similar. They will be more or less similar. So w will resemble some u, u will resemble some e. This strange approximant will resemble u, so it u, and u. And this is French guy that is u and u, 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 u. So something like this. And what we have next, we have exactly these French words. So we have oui and lui. And if you look here, I think you can see my mouse, aren't you?
We can.
Cool. So when we analyze, so here we have oui. So first one is, so it looks like it's a labial over there. And since U is have low formants, as you remember from the last lecture, we expect this formant movement over here. So we have low, we. So here we have this movement, and you see these formants over there. So those formants are merged. So this is the first formant, this is the second formant, and then you go back up to E, and you see this movement over here. So here is E, and this is the around 2000 hertz. And this is example. So when I said that U will resemble U, I need you to remember that U is more or less like E, but labialized. So this kind of sound is U that we have where? Do we have it in English? No, I don't think so. But maybe you borrowed something from French and then you have it. But I can make them from hand. But the idea that apparently we have it in Russian, but I don't think that everybody will agree. So for instance, when we have something like lublю, I think it's possible to interpret like lu, the first syllable, as having this u sound. It's also weird because if we try to sing this, the first syllable, it will change to u apparently. So it will be lu and so on. So when you turn and make it long, it will become u very fast. And maybe this is why it mostly interpreted as u after the palatalized consonant, not as the separate u sound. So, but why I'm telling it to you everything that I have in mind, because this U sound resembles E, and E has low first frequency and high second frequency. So since that, we don't expect for lui to change any to have any to have any changes in formant. So here we have le, and then we have u, and then we have e. This is the third formant that something is happening over here. And here, actually, this is what you can see when you work on semi-vowels. It's possible to see the first and sometimes the second formant, but the third and fourth formants are really blank. So they are there, but it's hard to see them. And here you see, again, more or less the same. So we have first, second, third, fourth. Then we have something, and then they merge, and some formats disappear. And then, oh, sorry, and then it E again, and you see first formant, second formant. For some reason, there is a gap here. And then third and fourth, and so forth.
So is this why we're saying that these are semi-vowels and not vowels?
Maybe that's why we are saying this. So you're asking why we don't interpret this as, for instance, diphthong, like U and E and U and E. That's the question?
Well, yeah, we can put it.
I don't know nothing about French phonology, but I expect that it could be a reason.
Okay, thank you.
But I've never thought about this way. What if we do some sketchy thing? Go to the Google scroll and how to how to distinguish sonorants from diphthong. And then it correct me with pH, and then not much. The boundary question. Maybe Google Scholar doesn't like questions. Not much. Oh, there was a typo. Maybe then get back to our previous search. So how to distinguish sonorants diphthongs? Okay. Blah, blah. Nothing much. Acoustic analysis of, yeah. This is actually tricky because
well, at the beginning you said that it was a matter of phonology.
Yes. It's more like, for me, it's more like a matter of phonology because the problem is when you work with diphthongs, you do care about formants and so on and so on. And people who analyze diphthongs will analyze them as vowels. And when people will interpret this as some sonorants, they won't do such an analysis because it's kind of constant. Why should we do this? Yeah, but so your question is there any actual difference between diphthongs and combination of vowel and approximant, non-phonological but acoustic one? Maybe there is one. Maybe, I don't know. Sorry, it become too philosophical for me. Okay, maybe go on from here. So I start thinking about what if we do such, or if we conduct such a research when we have a language that have this. Yeah, so imagine that we have a language that have, for instance, u and u, two sounds, and we have a diphthong, and they don't have such a word that ends. So they don't have a minimal pair. So they don't have like I don't know, liu and liu. So when you have a diphthong, it's actually also a matter of stress because when you have, sometimes could be distinguishable. So it's some parts of diphthongs could be separable. And then, for instance, when you have liu, it's clear that the second part of the diphthong is stressed. And it's possible to have liu, and then whether it's liu or liu, it's hard to distinguish. But I think it's possible to make some words that have it and then cut off something from one word and attach to another. This is weird operation, but it's doable. So we can sometimes prove this way. So you present two stimuli, one is generated and another one is not. And one, for instance, contains vowel and another something that is cut from the context with the approximant. And then you ask speakers to which word do you like more, or do you hear any strange things or something? I think the question which word do you like more will be make a trick. So if they don't care, they don't care. So the assignment of the preferred word will be random. If they do care, they will prefer the native one. And I think this way it's possible to prove that this is actually different things in their mind. What do you think?
Well, I'm a bit confused because I didn't really get how you, how we conduct the experiment. To be honest, I didn't really get it.
Like this. Go to prod,
Well, yes,
record some
that's
sound.
the easiest part.
No, sorry. Silence for a moment. We, Liu, we. And here we have something like, okay. It won't work for today, yeah. Okay, anyhow, we can see what's going on. And maybe it's
screen share.
I don't, yeah, okay. Here it is. So here is the, oh, it doesn't work for me for some reason. First quit, okay. So the idea that it's possible to cut something from the sound. We, you, you. So we have something like this. You can see the boundary over here. Maybe I turn off formants. So you can see that here I have W and then E. So you see this format movement, and it appears that vowels started from more or less here. Not anymore. I just cutted this and put it, I don't know, here. And then you need to go over here and make it work. It's hard, but it's possible. So you need to cut off maybe this. And here I get a clip. So you see over here. So this line is clip, clip, and clip. So this is a bad work, but it's possible to remove this clip and do some work on this and somehow manipulate this. But this is dirty work, and this is one work. I can't let you hear it now, but it's nothing nice. But this way, it's possible to manipulate sound and try to replace something that we treat as approximant and replace it with the vowel. So this the idea, I think.
Okay, I get it now.
Cool. Let's move on then. Kind of slow actually. So what time is it now? So we have something like 10 minutes, I think, left. Yeah, okay. So maybe we then move on. So here is the semi-vowels, like rhotic one. Those semi-vowels are produced so r and r with retroflexed one or not retroflexed one. Those semi-vowels are produced by raising the tongue toward the alveolar ridge, and this will be this position or retracted like in retroflexed one. And so what you get is something like it will be so the third formant falls yeah, so as stated here, third formant falls below the third formant frequencies typical of the neighboring vowels, so it will be adjusted over there. We can't actually see it here much, but it's over here. So again, first formant, second formant, and third formant, and then something is going on. And I think this is, yeah. So it's not like really clear. Yeah, this is a bad example, I think. But anyhow, what did I wanted to say with it? So the idea that those rhotic semi-vowels will do something like accommodation to the neighboring vowel, and this kind of trick that some semi-vowels do. I think that's what I wanted to say here. Nasal stop. Nasal stops are the separate topic, let's say. So since uvular is not forcing the area to be closed, we have more space. And we actually, the easiest way to model is to model uvular nasal. Why is it so? Because tongue and uvular are connected, so there is no any entrance to the oral cavity. So you have something like nasal cavity, you have all that we had before, and we actually can play around more or less the same way that we played with vowels, because it's a vowel that have different resonation frequencies, and this could be modeled with a tube that is a little bit longer, since it's not going to the oral cavity but to the nasal one. So we can play more or less the same way, and we expect that the frequency will be a little bit lower. So it will be for m, it will be 400 hertz, and then again multiplication, all odd multiplication of this. Okay, so here it is. It's nga, anga. So we have, so it has some formants. Again, it looks like it's not so intense like the vowel, the following vowel. So you see the intensity. So amplitude is high. So this is vowels are more intense. What's going on here? This is strange. Maybe this is he ends over here. Okay. So this is the area that we are talking about. So it's nga, and we have it as over here. It's not so intensive over here, and the frequency. So and here we have this format frequency. So I expect this will be 400. I'm not sure that it's true, but it's around it. And the next one is around 1000 and something. It will also accommodate to the following vowel, and since the vowel that we have here, I took this recording from the interactive APA chart website. So as you see, it's not saying much because there is no any changes in the formants over here, so they are more or less the same. Okay, so this is the first formant, this is the second, and there is some blob over here, strange blob over here, but for the rest, it's more or less the same. Anga, this is the another context, so we have vowel before and after. It's again, you see the drop of the intensity over here. 4 months, same. Strangely not the same, but I don't know what's going on here. So it's anga, aga, anga. Okay, so I don't know. So here it looks like a movement, but I'm not sure it's true. Okay, so what's going on when we have m? The strange story with the nasals that actually there is a part before constriction. So when the mouth are closed over here, so m, for instance, and you have something, and then it's actually possible to use different positions of before. So it's possible to put tongue over here, and over here, and you will get different nasal consonants. Actually, the place of articulation of the nasal is more or less clear when you release the closure. Because I really like this example. I will show it to you with like here. So imagine that I pronounce different nasals, but without release. So I have could you hear the difference? How many consonants I pronounced? It was just a trick to get the glass of water.
It was like you intended to pronounce both them and them and. I'm not sure.
Yeah, in most cases,
I was able to distinguish these two.
in most cases, yeah, they are kind of distinguishable because you open the mouth. When you open the mouth, then it's more prominent what's going on than when it's closed. You can tell the difference. But actually, the story was that I made different constriction in my mouth, and you can't hear much. Maybe this is because of the, I don't know, my mic, your computers, and so on and so on. But the problem will be that it's hard to say. It's not impossible, but because after the release, it's clear. Because after the release, it's amma, anna, and then how do you say it? Because of the vowel movements of the vowel of the surrounding vowels. So surrounding vowels will tell you what the place of the articulation. So it's not so important. So you don't need to care much during the production of actual consonant. Okay. So is it clear?
Yeah, I wanted to say that the experiment worked because I didn't hear the difference between like two sounds you were pronouncing.
Even between m and n?
Yeah.
Yeah, maybe. But I pronounced much more. So it was m, n, ny, and m, and then back. So it was like 10 of them. So yeah, maybe this first part will be a little bit longer today, because I want to discuss nasals and then we'll have a break, okay? So straight to the point. When we model nasals, so for instance, imagine that we have M. We have our tube that we modeled before, but we actually have an additional cavity over here. And this cavity will, it's possible for air to go there, and this will make it possible to stuck there, because when you have mouth closed, then it means that those frequency that this cavity resonates will be cut off from the source. And this is produced something that called anti-resonance. So the idea that we have some cavity over here, and those frequency that this cavity is resonating will be reduced. So it will be white spaces instead of black one that we've seen before. So before we've seen something like this. This is black formant. It's not so clear over here, but looks like formantish. But we also now will see some frequencies when something will go away. And I think those are frequencies that we expect. So around 1000 hertz, there will be some, so this is the anti-resonance frequency. And then again, every odd multiple is. Anti-resonance also goes anti-formant, as I said, and maybe we have, oh no, I don't have any examples here, but we can create some. And more or less the same logic could be used when we pronounce n and so any other nasals. So there will be some constriction, and after this we can finish. I think the next part is later. So now we can finish nasals. So first story about, so for all nasals we expect low first formant. We expect close spacing between formants. We expect the presence of anti-formants whose frequency are determined by the place of articulation. And this that you can find in nasals. And I think it's time to make a break, and then I think we'll meet in 10 minutes then. Okay. So now it's 32, so let's meet in 42. Can you type one in the chat, please? Okay. The next story that I want to tell you is about literals. Literals sound like l, or something. Could be analyzed the same way that we have some pocket over here, and then it will create some anti-formants. For this is this branch that we have over here is quite shorter than the whole oral cavity that we had before. So the anti-formant spectrum that we expect is around 2000 hertz. And I expect here some examples, but I don't. But we can do it like this. Allah. So over here, this is quite huge, and it's not around 2000 hertz, but this, so this part is vowel, then it's O, and then vowel again. And actually, it's really prominent for L sound or any lateral sound to have this gap around 2000 hertz. So you can see it everywhere. Okay. Maybe I don't need this. So the most complicated configuration for the vocal tract is actually vowels. Nasalized, and prenasalized vowels are really, really hard to analyze. So what is the difference between nasal and nasalized vowels? So it claimed that French have nasal vowels, and it's claimed that Polish have nasalized vowels. The difference between them is that nasal vowels are produced with the nasal cavity open through all the time, but nasalized vowels are produced with the nasal cavity opened after a while. So in Polish, we have, for instance, word, I don't know, they are, song, and it consists actually from song, so it's like song, and it became nasalized during the process of production. Pre-nasalized vowels doing the opposite thing, so they start like nasalized and then drop this nasalization. Pre-nasalized vowels could be found in Africa or African languages. So I think I can't remember, but we actually learned a tool today. So it's possible to do like here. It's okay. So let's do this and this. No, this and this and this. Whoa. Oh, they don't have it. They don't have prenasalized vowels. Whoa. that's strange. Maybe they have the separate notion in IP. Maybe this is maybe maybe this should be done like this. This is nasalized. No, how do you prenasalized vowels? No, it's consonant. I want vowels. Oh, it looks like that I make them up. Okay. Yeah, sorry, maybe without vowels then. Okay, sorry, yeah. So maybe prenasalized vowels is a fiction that I discovered. So, but anyhow, nasal and nasalized exist. So it's there. So the problem with those sounds is that they have a lot of different things to do. So they have the pharynx cavity, the mouth cavity, and the oral tract, and they are all opened. So maybe I get back, for instance, here. So imagine that the tongue is not up here, but just, for instance, backward, and we produce I'm not good in pronouncing nasal vowels because I don't know any French. So we have this tube over here, we have this tube over here, and we have this tube over here. So there are three like tubes, or here, but with this part opened. And it's really hard uh, to model. So the idea that we have uh, the oral tract that resonates with these 500 hertz and so on, and we have nasal cavity that resonates in 400 hertz. So we expect all of them to be present in the acoustic sound, and this is uh, could be true, but the problem with the nasal and nasalized vowels is that they are also not so prominent. So the intensity of the nasalized vowels is less than non-nasalized, than oral vowels. So this could be a problem sometimes because you need, in order to investigate this, you need to do a lot of work and a lot of preparing um, of the informant and asking them to repeat everything and so on and so on. And now we have with my student from Switzerland, we have the project, and she had their nasalized vowels, and this is a really pain. So there are a lot of there is some literature on it, but the analysis of those sounds is complicated. I think that's it for the lecture, and maybe we'll proceed with the seminar. Again, you can download this, and where do I have it? I have it somewhere in our folder over here. So we can skip this because it's more or less repetition. And I wanted to show today how to do something like this. Okay, I will do it, I think, in a minute. Okay, let's start. So first, what I need to close this RStudio. It's not important for now. I want to open Prot, and then I open the sound that that is present over here. So here we have a link to Nasals, and maybe it's work. Yeah, it worked. So I press Save As and save it somewhere over here. And we can go further. Okay, so here is Prod. I open the sound on desktop test. Here is my sound. I open this and here is my sound, and we can look at this. Okay, so we have some part. So what is there? And I think it's maybe I need to do something like this in order to remind me what's going.
Not A, not C.
Okay, so now we know what's going on there. So we have nasal. Sorry, we have label nasal over here, and nasal and dental nasal over here. We can see some that again the intensity is lower than the vowel. Here it's not so lower, but it's lower. And again, we actually can show intensity and see it over here. I don't know. Do you see it? Maybe not. Um, oh, it looks like I don't have any power on it. Okay, so anyhow, I hope you, maybe I can change spectrum settings so you can see the yellow one.
We can see it.
So I think this is better. So over here, intensity is going low up to vowels, nothing. Burst of the so, and then nothing, and then again vowel, and the same story over here. So you see those vowels again. Those waves of intensity over here. Here you can see that it's the intensity is actually merged, so it's not like here is the separate one and then another one, but the most intensive part is definitely the vowel. Okay, so in order to analyze this, so what we actually have been doing all the time, we look at this spectrum and doing something with it. So annotating, getting duration, maybe looking for formants, and so on. Behaves weirdly, but I want this. Okay, maybe I need to live with it. So what if I want to, so during the first lecture and second lecture, I all the time presented to you the momentum spectrum. So I presented something that looked like frequency on the x-axis and intensity on the y-axis. How to do this? So let's go to no way. Oh, it broke. Okay. Close then. Oh, that's what I needed to do. I needed to restart session. But anyhow, well, let's leave with this. I think it's not so important. So desktop, test, and the nasals, view indebted, and then we can go here and say spectrum and put here view spectral slice, or as you see here, Control plus L. And after this, you will see something that looks like this. This is actual spectrum from 0 hertz to 24,000 hertz. That is too much for us. And I think we can do something like view. No. View, maybe view. No. And it, maybe select from 0 to 5,000 hertz. And then select, and here we have our usual view when we have only a small amount of frequencies, like here. So here we have from 0 hertz to 5,000 hertz. And this is red line that we have over here. This is where we get those information. So as you see, there is some peak over here, and then something happened over here. So here we have 800 hertz, and this is this one, I think. So the next thing that we can see over here, something is happening. It's sliced here, so it's not visible. And then maybe something over here. And this is maybe so here 1,900 hertz, and it's about here. And then nothingness over here that we can see is present over here. So this is the huge gap that we can see on the spectrum. And then there is something in small gap again. So over here, and again, you can see it here. And this is momentum spectrum. So that's how you can get it for instance. And you don't care. It's not about nasals. It's possible to do with vowels. Here you are. But zoom to the some reasonable frequency range. So is it clear? Maybe now it's time for you to create your spectral slice.
Sorry, may I ask you a question?
Yes.
So the spectral slice actually shows us which frequencies are more like loud than others.
Yes. It's estimation, but yes.
Oh, okay. So maybe this is a stupid question, but how it is important for our analysis? So what like data we actually get from? What conclusions can we like get from this graph? I couldn't get it right now. Sorry.
So on the x-axis we have frequencies. On the y-axis we have intensity in decibel. In actually not intensity itself, but anyhow. And this is corresponds to color on the spectrum graph. So here you see formants, and this is the first formant, second formant,
Oh yeah,
third formant, and so on. Others are smashed.
Mm-hmm. Okay, thank you. I see now.
Cool.
So it's like for one moment of time, it's a
Yes.
graph. Okay.
And please type 2 when you created your first spectral slice. Okay, we have more or less 8 people, as far as I count. 9? No, 8. So do you have any questions? I think Aisha hadn't wrote anything. Maybe I'm wrong. Oh no, she wrote. Okay, so do you have any questions about it? I think it should be more or less clear. It's also possible to, so here we have this simple graph, and this is more or less interpretable. But it's also possible to create something like average plot for interval. So I select some sound, maybe over here, and then I have more or less 90 milliseconds over there. So I can do the same thing. So it will be spectrum, view spectral slice, and this will be weird like this. And it's impossible to do with it. So it's impossible to work with it, but so even if we zoom, we're not any happier. So there is an option, because every time we use it, we use spectral slice, it will create a new object in your prot objects window. So what you can do is you can again press view and edit again in order to do so. So you can I think convert this to LPC smoothing, and after this, let's use the everything that is there. After this, you will get something like this. Maybe this is not what I wanted. Hmm. No, it's not what I wanted. Why LPC smoothing is not working? This is weird. Let's make 10 picks. No, it's not alive. This is strange. Hmm. Can use this, but it's not what I wanted. It's also possible to use this, but it's not. Don't like this. Let's check it on vowels. Maybe here we have E. And then convert PC smooth and edit. Yes, it's reasonable for vowels, but standard. Okay, edit. Wow. Okay, so let's start from the scratch. First, you can use any smoothing algorithm that you want. I used to work with LPC smoothing, but for now I'm doing something different that I expect. But let's work with this one then. Yes. So I think the first thing that I want to discuss is what's going on. So what is smoothing itself? So, but it's not so beautiful then. But we convert capsule. So standard is 500. 400. Reasonable, but okay. So don't play with the. So let's use just uh, those thing that we have at the standards. So the idea that we have this 500 hertz so over here. So the idea that we have this smooth. So if you look here and compare with the original one that is here, and blah, 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 select something like this, you will see that it actually changes a lot. So here you have a lot of things going on, and it's actually not so weird as weird as I expected. And here is the smooth version of the same thing. It's not like visible over here because it's first peak, then second peak, third peak, fourth peak, and they are more or less regular. It's not what I actually expected, but anyhow. So this is 2, 5, 7. Weird thing happening, but I hope we'll deal with it. No, it's not here. So for some reason it's a little bit changed, but yeah. Okay, so let's start from the scratch because it get a little bit cozy. I think yeah, I will start from the scratch. So first, I showed that it's possible to analyze one spectral slice. It wasn't so messy. So it was select 5000 hertz. It's not 5000. Here it is. Select. We can inference formants from this. And here is the cat over here. Or maybe a wolf. So we can inference some frequencies, some formants from here and analyze this. But this is value from one point, so it's actually depends on where do you put this point. And it's possible to use the average value. So imagine that I select the whole sound, and then after this I get this. That is messy to analyze, but when we zoom, it become clearer. And after this, we can actually take this and smooth. So here we have a lot of values, but it's possible to make them more to take the signal and reduce the random noise. And this could be done with the if you go to the object and use some smoothing algorithm, and there is LPC smoothing that is linear predictive coding. So that's an algorithm for this. And for some reason, this sound get so the level of the smoothness is too high. So what we get, and I tried to reduce it. So I need to number of peaks. I need to I don't know 15 peaks. If I increase it, it will be more peaks over there. So we achieve something over here. So what we get some peak around 4. So if you go there, so this is the plot that we see. And we see something like something happening around 2000 hertz and 4000 hertz. So this is even counterintuitive because in about around 4000 hertz, maybe this is happening around 4000 hertz. So if I take this, it will be more similar to what's going on there. But this formant structure was reduced, so we lose information, and this kind of smoothing is not good enough. So maybe let's do 50. This is weird number, but maybe it get us to the better level. So 5 over here, no. 5. So here we have peak around 4. Yeah, around 5 or 400 hertz. This is probably this. The next peak around 1600 hertz. This is here. and then everything go down to around maybe 3000 hertz, and this is probably this valley over here. So if you increase the number of peaks, then it will be possible to capture something that is not smoothed out. Let's select a new sound. So over here I have, again, this is N. So what can we do? We can again select 5000, go there, and it's not visible at all. But if we go here and use convert LPC smoothing and use the same number of peaks, so 50, then after this it will be not so, it will be smooth. So you can analyze this way. So here is the peak about 400 hertz. This is probably this one. Let's merge them. Okay, so it's probably this. Then we have something happening around 1500 hertz. It's this one. The next one is 2400 hertz. This one. This is the valley that we see. This is 3800 over here. And then some new peaks over here, and this is what we see over here. For N, for some reason, it's more clear than for others. Okay. Is it clear what I'm doing and why I'm doing this?
It's clear what you're doing, but I'm not sure why you're doing this.
Okay. So on the different lecture, I think we captured information about duration. So we annotated something, get the duration of something, and leave with it. For now, what I'm trying to do is to create a plot of spectrum and generalize this across the whole sound. So afterward, it's possible to compare different class of sounds. So for instance, M and N, what kind of spectrum do they have? And you can do this plotting on the same plot. They obtained, so maybe here it's possible to do draw from 0 to 5000 hertz. Okay. And then we change pan to something red. And this is N. And probably this one is, so this one, the red one is M and the black one is N. N like nasal and M like Moscow. And this way you can compare different spectrum of different sounds. And we within actually created an article that have more or less the same plot. I think it's here. So this is the frequency, and this is the plot of the S sounds, because we analyzed S sounds. And those are different speakers. maybe it's not so beautiful. This is weird. I even can't remember that we had it. Okay. So this plot that I wanted to show you. So is it clear why do we need it? So we have two similar sounds, and you want to show that, for instance, one has frequency, some format in the some frequency A, and another have higher frequency. Then you can compare them this way. Okay. So as you guess, probably, your next task will be to create more or less the same plot as here. So first, what do you need? You need to go to the sound, then select the some sonorant part. Then you press Control L or press View Spectral Slice, and then some new object appears. Then you convert it to LPC smoothing. I used 50 pix in order to get it better. And then after I obtained this graph, I used function draw over here and I put it here 0 and 5,000.
Sorry, we don't see your screen.
Sorry. Should I start from the scratch? Okay, maybe I will start. So you have here the nasal. I select nasal and press Spectrum, View Spectral Slice, and then something new appears over here. Then you convert it to LPC smoothing with 50, number of peaks 50. Afterwards, you will achieve something like more smooth spectrum. And I suggest to use those values in order to use draw, and then here choose the frequency range, and you need to choose actually minimum and maximum power in order to have them in the same range. So for instance, this one is from minus 33, minus 34 to, maybe it's not so. So minus 30 and plus 30 should work, I think. Blah, 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 where do I have it? Probably here. Yeah. So after this, draw them on this using draw. Using draw function, and use minus 30 plus 30 over here. Will it work? Okay, no. Plus is not here. Then go there, change color to something else, and draw another one in the same range. And then you have the plot of two lines that are in the same range, and they are comparable now. And this is a task. And ask questions if you have any problems. So I will help you, hopefully.
So the sample is printed in the website, the antique nasal.
So the sound
So
is on
the
the
sound we
website.
need to analyze.
Sound is on the website, but you can use any sound you want. So you can record you saying ma na and then create the same analysis. Do you have any questions? Oh, everybody just gone? Okay. Should I help somebody with the script or prod or something? If you have any questions, just ask.
How do we save this picture?
Really good question, I think. File, save as PNG. Here you are. And after this, you can print it. Here it is. Print and put on the wall.
Thanks.
Oh, that's 3 means that you've done. Oh, that means that a lot of people have already done. That's cool. 1, 2, 3, 4, 5. That's a lot. Since we have only 9 people and I'm not doing anything, that means that the only 4 left. I insist on asking questions, so it's really helpful. If you have any trouble, please do.
Can I?
Yeah, Jonathan?
Okay. Yes. I'm trying to catch up. I'm very sorry, but I have some problems with my computer at the beginning when you explained the first part. But I think I got the majority of what you said, but I just get sort of a strange output. Can I share it? Can I show it?
Yeah. I'd happy to see.
All right. Just 1 second. Okay. Oh, sorry. This is what I get. Maybe I did something wrong. I told you I couldn't hear at the beginning. I had some technical problems. But this
Okay.
is what I get.
That happened because it looks like that you drew a lot of things. So first, let's go together with this picture. No, with
okay.
picture. Yeah.
Okay.
And erase everything that you've done. I know maybe it's hurtful. It's edit, erase all.
Erase all. All right.
Okay. So then if you put mouse at the beginning of the on the left top corner.
Mhm.
No, a little bit lower.
Lower. Okay.
No, then upper. So the idea that if you put there. So the idea that put there at the beginning. This pink, yeah, and then try to drag. So for instance, no, yep. That's what's going on, and this is the border of the pictures in prop picture.
All right.
So maybe make it a little bit bigger, because now it's smallish. No, but not selected, just with the mouse.
How can I make it bigger with the mouse?
No, the idea that now it's from 0 to 3, as you see.
Mhm.
And it's possible to make, for instance, from 0 to 6. On the x-axis, I think it will
Here?
be enough. Yeah. Perfect.
Okay.
Perfect. Cool. So now let's go to your prod objects window.
It's over here, right?
Yeah, it's here. And I think, could you press view and edit and show what's going on over there? Okay, it looks like it's smooth, isn't it? Is it smooth version?
Yes, I think so. I don't know if I chose the right part of the recording.
Yeah, no, looks good. That's perfect. So let's plot it. So then close this, and let's try draw, and then I would like to have frequency range, because now it's from 0 to everything, and this will be bad because it will print you every 22,000 hertz, and this is too much. So I would say at the beginning 0, and this is perfect. But at the second tab that you see, I would type 5,000 hertz, just 5,000, and that's all. Yeah, cool. And now I would like to have garnish. Yeah, because yeah, have it, and apply, and you have a beautiful plot. After this, let's go to the prop picture and change the color so it's in the pen, and then whatever you like. Cool, it will be pink. So now we can go back to prop. I think you silver. Okay. And now we can go to this part and select another spectrum slice that we are happy with. So this is one that we already plot. We have in the plot. 13 is on the plot. So do we have any other spectrum slice over here? Smooth spectrum slice.
I'm not sure. Maybe it is. Let me see. Is this one?
No, that's not smooth.
We get smooth one.
No, it's spectrogram. It's not.
Should also generate it from the.
We can get back and just generate another one. So what do we have on the left, by the way? Is it N?
I'm afraid I'm not understanding that. Do you mean here in this part?
So the 13 spectrogram, this one. Which sound is it? Is it M or N?
Oh, I have no idea, to be honest. Can we see it? Is there a way we can check it?
I think there is a way to do it, actually. I would say that this is N. Yeah, I think it looks like N. So let's go to the beginning of the recording where we are. Select some M part at the beginning.
Here?
Yeah. No, it's I would suggest to do so. The you see central part is vowel, the most intensive part, and it's a burst. So get back. So here, yeah, this is the vowel, and before the vowel, I would select before the vowel, even before. So let's say from this one, but look at the spectrum. You see where it starts on the spectrum.
Over here?
Over here, yeah, maybe a little bit further, but we can live with even with this. So
okay,
let's
like
select. No. I will select from the beginning to vowel, to the start of the vowel. And vowel starts when the format starts. Yeah, over here. Yeah.
Okay.
This is nice. There is some silence over there, but anyhow, we can live with it. And then let's press spectrum and spectral slice. View spectral slice. Yes, cool. So we have it, and now we need to smooth it. So we can close this. We don't need anymore this window. We don't need, and we don't need this window either. And
Oh,
the last one is M. So
mhm.
now analyze. Oh, sorry, convert.
50 was all right, isn't it?
Yes, cool. Perfect. And now we can draw this. Draw. And the one trick is that, sorry, stop. One trick here is to switch off garnish, because this is actually all axis, all y-x annotation and y-x annotation, and it will be in silver if we draw it now. So now press apply. And you see there is a new line on your plot. It's a little bit, for some reason, a little bit hidden, but maybe this is a problem of the, yeah. And now you can save it if you'd like, but you need to select in order to save, because it's saving everything inside this pink pink area. So you need to select and even further. Yeah, over here. And now you can select and save it somewhere. Maybe 300 dpi will be enough. Okay, cool. I think you have done this, and now we see the music that you listen and
Ouch.
sorry. Okay, so maybe stop sharing for a
Thank
moment.
you. Thank you very
You're
much.
welcome. I wanted to show you another thing that we can do. So now we plotted in Prod. Prod is not a nice tool for plotting everything and controlling everything. So I would like to go to Prod objects, remove here, and here is my, yeah, probably here is my smooth spectrum. And it's possible to use tabulate function in order to create a table. So it's just a simple table with a bunch of values. So here is the frequency, and this is the power value over here. And after this, I want to go to save as comma separated file, and go here, and this is probably N. I will name it N. For some reason, Pratt likes to add extension table, but I would like to have CSV, but it doesn't matter, actually. And over here, I had another, not here, probably here. Yeah, over here, I have another spectrum, smooth spectrum, and I want to tabulate. Okay, save as comma separated file, and this will be M. CSV, save. And after this, it's possible to create a plot of this, but for some reason, this is not the plot. This is not the code that I want, and this is not, and this is not. Something interesting. So imagine that I have a new script, and I added a new script over here. So here on the website, I added a R script for visualizing spectral slices, and it looks like this. I just copy it from here, paste it from to here, and the only tricky thing will be set working directory, because I need to set it somewhere. I will use home, something like this, test, and then I have all my files over there. Go to working directory, cm csv.m.csv, n.csv. So for now, I'm ready to read it. Okay. because it called m.csv and m.csv and n.csv. So now I'm ready to read it. And this is a simple table as we've seen before. And what I'm doing here is adding a new column with the value n. So after this, if I call n, it have a third column that's called sound type, and that's a repetition of the same letter n all the time. And after this, I do the same with m. So I have the two tables of the same structure, and I merge them together in plot using with a plot. And here is this function will merge them together. This function will filter only those values that, in order to have values from 0 to 5,000 hertz and not to 22. And this is just drawing. So this is the X value, Y value, and color by sound type. And this is how do I draw it. So this is the script. And this is how you can plot, create more or less the same plot in Prot. For me, it's a little bit more convincing because I can do a lot of things in Prot. So, in R. So I can change theme. I can, I don't know, write down something like this, caption data from Andy Village Zilo, and then it will be everything on my plot. And maybe I need to annotate X equal, I don't know, frequency, Y is intensity, and it will be beautiful as I want. And maybe color also should be annotated. Color equal nothing. And then I will create the beautiful plot that could be used everywhere. But if you don't like R, it's possible to use Prot system, visualization system. It's just a little bit tricky to work with, and it will be impossible to plot, I don't know, something like 100 lines using Prot system. So this is the script. Maybe I will update it a little bit. So maybe this is not important part. This you will learn during your R classes, but this you will see on the course web page. So over here, there is a link. I will update the code. Do you have any questions? You're like a little bit overwhelmed, but okay. So let's call it a day. No. Have a good evening. It appears John don't have any evening yet. So the rest of the day, let's say. So nice to see you all. I hope that see you next week. I don't know, maybe it will be my lecture, but maybe it will be Inna's lecture. We will talk about it. Okay. So bye.
Thank you very much.
Thank you. Thank you very much.
Thank you.
Thank
Goodbye.
you. Bye.
Bye.
Bye.